So in this video I will explain a sphere problem. So the question given is two sphere each of radius 100 mm and weight 5 kilonewton is in a rectangular box as shown in figure. Calculate the reaction at all contact points. So the contact points are D, C, E as well as in between the AB. So this is the given problem. So in this sphere problem, first thing what we have to do is first we have to draw the free body diagram. For free body diagram, first we have to see that how many contact surface are there, what angle the reactions are making. So in this case, this reaction, always the reaction will be the normal or the normal to the plane or the perpendicular to the plane. So this makes a 90 degree with the this line, this makes 90 degree with this line, this make 90 degree with this line, and this makes 90 degree with this line. So if I get the reaction like this, then I should know the angle. For the calculation of angle, what we used to do is here they have given the rectangular box size of 300 mm and they have given the radius of the sphere is 100 mm. So we can see that if this is a complete 100 mm, the radius is 100, so complete it will be a 200. So from here to here is 100, from here to here is 100. If I draw it or if I mark it, so from here to here is 100 because the radius is given. Similarly here. Okay, so just I'll drop the line from the centroid of the sphere or center of the sphere, and again I'll drop it over here. So if this is 100, this is 100, so total will be 200. So 100 plus 100, 200. So total is 300. If I deducted 300 minus 200, so I'll get 100. So this distance what I'll get is 100. Okay, so this is here 100 mm. Now similarly, from here to here is 100, from here to here is 100. So total will be as 200. Clear? Like this you can get the distances. So if I calculate the angle, so I'll consider this a triangle. So the triangle will be like this. So where the forces are acting along that force direction. So we'll calculate the angle for that force. So the opposite side is don't know. We don't know what will be the distance, but we know the adjacent sides of that, which is 100, and the hypotenuse side of that, which is 200. So if we use the cos of theta equal to, we know that cos is nothing but here base by hypotenuse. Base is 100 or the adjacent is 100 and the hypotenuse is 200. So theta will be cos inverse of 100 by 200. So we'll get theta as cos inverse of 60 degree will be 0.5. We'll get a 60 degree. Cos inverse of 0.5 is here 60 degree. So we'll get angle as a 60 degree. That means the reaction produced between these two making an angle of 60 degree. Now I'll draw the free body diagram. So first, in a free body diagram, generally whatever the component or the contact surface reaction produced, that you have to show it. Then the self weight of the sphere. Okay, so in this case, here there's a contact surface, here there's a contact surface. I'll just draw a line over here. Again for this, in the same direction it will act, and there's a contact surface over here. Okay, so this will be the here I'll write RE, that is reaction at the E point or the contact surface at the E point. So there is a RD, then there's one more reaction which is RC. Okay, so this case it will have the reaction on the sphere A. So I'll write RBA. So this will produce the same reaction which is RAB. Okay, so these are the reaction what we'll get. Along with the reaction we'll get a self weight of the sphere which is given as a 5 kilonewton. So there's a 5 kilonewton self weight. So here I'll show it either above or at bottom, you can show it anywhere. Okay, so I'll get 5 kilonewton. Okay, this is the here I'll rub this part. This is the your free body diagram for two spheres. Okay, so in both the cases we can see that it has 4 reaction or 4 member forces, here 3 member forces. So if I take this, the unknown will be 3. Okay, it will be very difficult to calculate the your reaction, or we can say you cannot calculate, because the forces are concurrent force system. When you have concurrent force system, then we can apply the condition of equilibrium, which is summation of Fx and the summation of Fy only. So with the help of that we cannot calculate this. So I'll move on to the sphere 2. I'll consider the sphere 2 and this sphere 1. So in the so if I draw the free body diagram, joint diagram for the sphere 2, then it will be like this. So this is RE reaction. This is a 5 kilonewton load. Then there's a RAB reaction. We cannot consider this in the second sphere. This reaction will act on this support, because this sphere will produce reaction to this sphere. So that time when you are calculating the or taking the joint diagram for the sphere 1, that time RBA will be used, but whereas it here RAB will be used. Okay, so RAB. So the sphere A produces a reaction on the sphere B, and the angle what we have calculated is 60 degree. Okay, this is the joint diagram. So these are the 3 forces, 3 member forces. With the help of this 3 forces, we can calculate the unknown force or unknown reaction RE and RAB by use of Lamè's theorem. So we know that if you apply the Lamè's theorem, the forces either should be a converging is nothing but meeting at a common point, diverging is nothing but going away from the common point. Okay, so that time what we'll do is we'll rearrange this to in a such a way that it should be a converging or a diverging fashion. So what I'll do, I'll draw the one more time or rearrange the forces. So RAB, I'll take it on the first quadrant. So we know that the principle of transmissibility, if I force is transfer from one point to the other point, it will remain in a same condition. Okay, so with the use of that we can apply the transfer the force into the respective coordinates, so that it will act in a such a way that all the forces are diverging. Okay, so this will get the 3 forces. The angle with respect to horizontal is 60 degree. So we can apply the Lamè's theorem. So for the calculation of the Lamè's theorem, we should know the angle between all the forces. So in this case, this is 60 degree. So total angle will be 60 plus 90 will be 150 degree. Similarly, this angle will be 90 degree. And this angle will be 90 plus, this is 60 means 30 this, and 90 this will be 120 degree. Okay, we'll get the angle like this. So we can use your Lamè's theorem formula, which said that the magnitude of each force is proportional to the sine of angle between other 2 forces. So first I'll consider the 5 kilonewton force, which is proportional to the sine of angle between other 2 forces. Other 2 forces are RAB and RE. And the angle between them is 120 degree. Similarly, RE sine of 150 and RAB sine of 90 degree. Okay, this is the equation we'll get with the use of your Lamè's theorem. So I'll consider these two to calculate RE value. So I'll write RE sine 150 equal to 5 divided by sine 120 degree. So if I take RE this side and 150 on the other side, sine 150 on the other side, so it will be 5 into sine 150 degree divided by sine 120 degree. So if I calculate the RE value, so RE value will be 2.886 kilonewton. Similarly, if I calculate the RAB, so I'll write RAB sine 90 degree equal to 5 divided by sine 120 degree. So I'll keep RAB on one side and the other forces, the sine 90 on the other side. So it will be 5 into sine 90 divided by sine 120. So RAB value what I'll get is 5.773 kilonewton. So these are the reaction what we'll calculate with the considering of joint figure 2 or the sphere 2. Now we have to take this to calculate the your other forces. So I'll rub this part. So now we'll consider the second joint. So I'll draw the joint diagram of that. So there is the one reaction which will be produced by the second sphere, which is RBA. The reaction produced by sphere B to sphere A. Then there is a load 5 kilonewton. Then there is a reaction RC. Then there is a reaction of RD. So if I calculate, already we have calculated the angle. This makes an angle of 60 degree. Okay, already we have calculated the value which is RAB, which is nothing but how much? 5.773 we got. Okay, so now the two unknown forces are there. With the use of your equation of equilibrium, we can calculate the RC and RD. So I'll use the first condition as a summation of Fx equal to 0. If I consider the summation of Fx equal to 0, then I have to resolve the force into the x component as well as the y component. The x component will be RBA cos of 60 degree, which is moving left side. So minus RBA, I'll directly write the value which I got, 5.773 into cos of 60 degree. Then RD, which is moving right side, so plus RD equal to 0. So RD equal to 5.773 into cos of 60 degree. If I calculate, so I'll get RD value as a 2.88 kilonewton. Okay, so this is the RD value. Last the reaction what I have to calculate is, which is RC value. RC value can be calculated by using the summation of Fy equal to 0. So first component I'll take RBA sine 60 degree, which is acting downwards. So minus, I'll write the value of RBA, which is 5.773 sine of 60 degree minus 5 kilonewton load, then plus RC equal to 0. If I take all this term on the other side, it will be 5 plus 5.773 sine of 60 degree. If I take it, so I'll be getting RC as a 10 kilonewton. So somewhat I'll get 9.99, so that will be 10 kilonewton. So RC will be 10 kilonewton. So all the reaction what we have calculated, the values are RD, RC, RAB or RBA, then RE. So RE what we got is 2.887, RAB what we got is 5.773, RC is 10 kilonewton, RD is 2.88 kilonewton. These are the reaction